AviationPros.com is the portal website for AMT, Airport Business, and Ground Support Worldwide magazines. Visit daily for breaking news, industry blogs, and insightful articles from our magazine's editorial team. And don't forget to sign up for our publication's daily e-newsletters. It's all at AviationPros.com. In this episode of the Aviation Pros podcast, Phil Cole, Civil Aviation Business Manager with Aerogility, joins us to discuss the ways artificial intelligence can improve maintenance operations and scheduling, along with detailing how the technology has evolved over time and where AI still needs to grow. Phil, thank you again for taking the time to chat today with me. To kick off our conversation, could you start by sharing just a little bit about yourself and Aerogility for our audience?
Hi, Walker. Yeah, thanks very much for the opportunity to join you on your podcast. My name is Phil Cole. I'm the business manager for civil aviation at Aerogility. I have been with the company for about 5 years now. We're a software company specializing in model-based artificial intelligence. And our modeling and scheduling tools are used by companies like Rolls-Royce, Lockheed Martin, EasyJet, Scandinavian Airlines, just to name a few. Our headquarters are based in the UK, and we also have a small presence in Dallas in the US.
Very good. And our conversation today is going to be focusing around AI. And to give our audience a little bit of introduction for that, can you just tell us what AI is when we're talking about it in relation to aircraft maintenance?
I'll do my best. AI is a term used a lot and can mean many different things, and everybody has their own interpretation of what they think AI is. But essentially, it is a machine doing something that we would consider intelligent if it was done by a human. And an example would be something being used in the aviation industry at the moment is machine learning linked to multiple sensors on aircraft. And these aircraft produce huge amounts of data and the performance of the various elements on the aircraft. And the machine learning algorithm goes along and it predicts, based on historical data, when a part might be coming to the end of its life or about to fail. And it is having a huge impact on aircraft maintenance, particularly in the preventative maintenance field. But not all AI is machine learning. And Aerogility's area of expertise is in model-based artificial intelligence. And our models, they represent concepts understandable by people. I suppose these concepts are represented as agents within a model, and each with its own set of rules and constraints and relationships to other agents in the model. An example could be an aircraft that is accruing life over time, or an MRO base with a number of tracks that define its capacity and ability to perform maintenance. We create scenarios with these agents that allow the agents to behave and interact autonomously within the boundaries of the scenario. For example, a time period, so we'd run a scenario for 5 years to predict the maintenance requirements for a fleet of 300 odd aircraft over that period of time. The use of agents makes it much easier for humans to interact with the model and to understand and interpret the output of the models. It allows us to represent complex real-world scenarios. For example, an airline operator with aircraft accruing life through flights and routes and MROs performing the maintenance, etc. And this easy interaction allows us to start to ask what-if questions. By modifying an agent parameter, for example, an MRO might say, a C-check is going to take a little bit longer now. So what is the impact of that on your maintenance requirements? And those kind of changes to the model are very easy to execute and then compare the output to previous results. And this modular, agent-based model approach, it allows the decisions made by the agents in an execution of the scenario to be traceable and allows us to understand the reasoning the model applies when making its decisions, which makes it the traceability that then starts to allow us to being able to understand the reasoning that the model applies um, helps us to trust the results. It ensures safe, what we call safe and trusted results. So slightly, obviously, it's a different approach to something like a black box algorithm where you chuck a whole bunch of data in, and then you get some results out the other end. Now, those results, generally speaking, are excellent, but we don't know what happened in the black box in order to give us those results. And the model-based approach, you can trace each and every decision made by the model through an execution of a scenario to get a greater understanding of the reasoning applied. So using these agent models in the aircraft maintenance sphere allows the planners to consider many more factors when creating maintenance schedules and maintenance plans, and ultimately allows them to move away from their two-dimensional spreadsheet solutions.
So, what then has this technology's history been, and how has it evolved?
Well, the concept has been around for a long time, and obviously the advances in computer technology have run alongside the evolution of AI and model-based AI. We, as a company, did some initial R&D around it in around about 2008, and identified an opportunity for its application within the aviation sphere. And we have been maturing the product since 2009, and we've got a pretty good set of models now. And the beauty of the agent-based approach allows you to start small, build a small model with a few agents in it, verify the output, and then slowly but surely start to add complexity, verify and add and verify until you can get a really rich, complex model, giving you some real world results to use to execute your plans and produce plans.
And so, then where are we kind of with it right now? What are all the possibilities that AI can do for us?
Again, I'll only answer that from our perspective, from a model-based perspective. We've got two types of models that we use. We use scheduling models, and at the moment largely used within the civil aviation sphere, and used to produce heavy base maintenance programs alongside landing gear removals. And those landing gear removal plans, are predicated on the availability of spares. We also do power plant shop visit scheduling, and again predicated on the availability of spares. So we don't have a schedule, bringing an aircraft in and then leaving it on the apron whilst waiting for a spare engine to be available, and also end of lease planning as well. So those from a scheduling model perspective, all the aspects of maintaining an aircraft and performing the maintenance. We also have some probability-based models, which allows us to add stochastic functions to our agents to model a probability of failure. And then we can start to build some really rich models that are very useful for things like capacity and supply chain planning. And these are the kind of models that we do like a 100 iteration Monte Carlo run of the model, which we then aggregate the results, and then that will help with any decision making going forward. In fact, quite often we will refer to our models as decision support models.
So then, how can an aircraft maintenance operation get started with AI? How can they begin incorporating it into their work?
Well, gratuitous plug here. Call me. It's we're pretty versed certainly in model-based AI. We've got, as I said earlier on, we've got some very high-profile customers already who use our models. So yeah, get in touch, and if you want a demonstration of what we can do, more than happy to do that. But essentially, yeah, just get in touch, and we'll do our best to help you out.
Then, what are, if any, some challenges with AI, and how are they overcome?
So there is, as I mentioned earlier, there is still a little bit of an issue of a potential issue of trust with AI, and especially around black box and neural network type solutions where you can't necessarily always determine exactly why a decision is made or why you received a specific output. And another issue really is the amount of data, so data-driven AI, the amount of data that is being produced by aircraft and all of the plethora of sensors that they have on them is vast, and we really need to be able to sift out the stuff that we don't need and drill down to the stuff that's useful, and then we need to be able to provide that to the end user in such a way that it is meaningful, and that's where something like Aerogility can be complementary to some of these more these black box solutions. They can do all the data crunching and drawing all the correlations between data items and start to produce health indicators, and then you can use a complementary solution like Aerogility to then overlay that with your plans and present it to the planners in such a way that they can actually start to incorporate this information into their plans and make sure that preventative maintenance is achieved in a timely manner.
And that's a perfect segue in my next question here. What is it that people are still kind of better at with AI? How can people and AI complement each other the best, and how is that going to change as we move into the future?
Yeah, so AI hasn't really mastered replicating natural intelligence yet, and many people would say that's a good thing. There are plenty of movies out there that highlight the potential downside of it. So AI algorithms, they detect relationships through correlation without necessarily understanding the relationship. So this also means that they then have a high probability of detecting spurious relationships and implied causation. So I'll give you an example. If you were to analyze a city hospital's heat stroke through the summer, the number of cases of heat stroke through the summer, and also the sale of ice creams in the same city in that summer, and both the peak of heat stroke and ice creams are at the same time, an algorithm might imply that ice creams cause heat stroke. So that's why we need humans to analyze the output and sift the meaningful from the meaningless, and then act accordingly. So, and as I mentioned earlier on, we refer to our models as quite often as decision support systems. So the AI is there to do all the heavy lifting, and present results to the humans to then analyze and make the best decisions possible based on the data provided to them.
Phil, I think those are pretty much all the questions I have for you. But before we wrap up our conversation here, any final thoughts, any final advice for our listeners about how they can start utilizing this technology?
Yeah, so in terms of utilizing the technology, as I said earlier on, call me and we'll help you lose the spreadsheets, because there's only so much you can do with a spreadsheet, and I feel your pain for those of you out there who are still having to use them and to schedule maintenance, for several hundred aircraft at a time. So we can the models that we got have helped all of our customers to improve their productivity and improve their yield and reduce their costs, and increase your availability of the fleet. So those are the kind of things that we aim to help our customers with, and we would love to help.
Thank you for listening to this episode of the Aviation Pros podcast. Be sure to visit AviationPros.com for more stories, breaking news, and expert insight from all around the aviation industry.